everyone. In this video, we're going to talk about dilution of a solution. So kind of rhymes there. So diluting something, most of you have used this term before and can relate it to something. So if I go to the gas station and fill up a sweet tea and it is too sweet, it is way too sweet for me. So that is telling me that it's way too concentrated with sugar. Okay, therefore I am going to do what? What can I do at that point? I can't take out the sugar, right? There's no way for me to pull it out. So what do? I add some water, right? I dilute it. Okay, so we do this a lot, whether it's in cooking or in our drinks that we prepare or whatnot. So basically all you're doing when you dilute is you're adding solvent to decrease the concentration. So makes sense, right? If you add more solvent to it, it dilutes the solute. Okay, the big thing here that students lose sight of is when you dilute, you're not changing the amount of solute that I have. So just like my sweet tea, if I start out with this much sugar and I dilute it, I still have the same number of sugar molecules. The only thing that's happened is I have a larger volume, right? I've added solvent. That's the only thing that's changed. So we can do dilution calculations and we can figure out, okay, if I start with a certain concentration of volume, I can find out what my concentration or volume would be if I dilute it. Okay, and so just like all of our other equations, here we have 4 variables. Okay, if I have 3 of the 4, then I can solve for any of these here. Okay, 1s are initials values and 2s are final values. M is for molarity, which we discussed in the previous video. V is for volume. If you're given V1 and V2, you can use milliliters or liters, but be consistent. Don't use milliliters and then use liters. Okay, so we want to know the concentration of a solution formed by diluting, so key word here is dilute, 5 mils of a 3.2 molarity glucose solution to 40 milliliters. Okay. Let's clarify this real quick. All right, so let's identify. Here's my V1, that's my initial volume. Here is my initial concentration, and here is my V2. So I am looking for M2, so that's my final concentration. So pretty useful here. We can figure out what the concentration is going to be after we change the volume. We dilute it. We start with 5 milliliters and then it goes to 40. So M1V1 equals M2V2. That's the equation that we need to know. If we want to solve for M2, that's what we're looking for, then we divide both sides by V2 and we rearrange it, and there it is. So we can rearrange it. It's real easy to rearrange. It's linear. So you just divide by whichever side you need to there. And then you just put in your numbers. So M1 was 3.2, V1 was 5.0, V2 was 40. Once again, our units cancel. They always do, to give us molarity left over, which is what we're looking for. And so we get 0.40 molarity. So our concentration when you dilute is going to be less, right? So if you get a bigger number than 3.2, you know that you did something wrong. Okay, so you go from a molarity of 3.2 to a less concentrated solution of glucose to 0.40 molarity. Right, a practice problem. Have it written out already here. So we'll just talk through it. We want to know what volume of an 18 molar sulfuric acid is required to make a 2.50 liter solution of 2.40 molar sulfuric acid. So here we're given the finals. So here's V2 and here is M2. Okay, we're looking for V1. Okay, and here is M1. All right, so we are looking for V1, so we divide by M1. So there's our rearranged equation. So M1 V1 equals M2 V2. M2 was 2.50 liters. Our, V2 was 2.50 liters. M2 was 2.40. And then our M1 is 18.0. So basically you just rearrange, plug in the numbers that you're given, and this would be your answer. So in liters it's 0.333 liters, or we know if we move our decimal 3 places over, multiply times 1,000, we can get milliliters, which is 333 milliliters. So you just have to read the problem carefully, figure out what you're looking for, and then rearrange. And the key here for dilution is that you are not changing the mass or the moles of solute that you have. The only thing that's changing is the volume, okay, which hence will change the concentration. All right, thank you.